Hey everyone, welcome back to my channel. In this video we will make a nice license plate detection and we will use the easiest method using the machine learning OpenCV. Hey there guys, welcome back to my channel. In this video we will make an car license plate detection. Okay, so I have this car image. Okay, it will be also again hard. Okay, and you can see the number plate. So it will scan this. Okay, it's from Tamil Nadu, okay, and I have an Cascade for plate number. Okay, you can see that this is an XML file. It will not take that much memory, but the length of that file will be 2656 lines, guys. Okay, the lines that are used are very okay, as you know. So in today's video we will use Pytesseract. Okay, Pytesseract. What's the use of it, guys? Okay, so Pytesseract will help us to do some functions of OCR. Okay, first just open your terminal, install the module. Okay, after installing the module you will need one more thing is to install the application. Just click on the 32-bit or any bit. My system is 32-bit, but I think that actually my system is 64-bit, but 32-bit will work. Okay, so till it's downloading, let's import our modules. It will open when it completes. Okay, it's now opening. Till that time I will just write my imports. Say here yes. Okay, say here yes, and you can see right over here. Okay, it's saying please wait while setup is loading. Select the language. Okay, simple. Just say next. I agree. Install for anyone using this computer. Okay, next. Just keep it those two that it has, and say next and next and install. Okay, when it completes, say next again and finish. Okay, when it completes, you have to hit Windows R. Okay, right over here type C:\\. Okay, program file wherever you have installed. It could be any location, and type here Tesseract OCR. And after that, what we need is the exe. Okay, just copy it and close it. Just go to your VS Code. First, let's import our modules CV2, numpy as np. Okay, and then the module that we have just installed means Pytesseract. Okay, here say Pytesseract and then Tesseract command. Okay, if you don't worry about these two links, I will give these in the description, guys. Okay, equals to right over here, just paste it. Okay, just paste everything right over here. I'll just make the C capital. Yes, so this is the location of the Pytesseract. Type here R. Okay, so it will be reversed. Everything will be reversed, or let's reverse it ourselves only, either than being that much lazy. Okay, so we have set up our command. Okay, means now we can work with the command Pytesseract.image to string. So it will directly convert it while calling it. Okay, here we just need to specify the image. But what we will do, you know what we will do? Right over here, after writing the command, for processing, what I will do is let's create a function for it. Okay, I'll say here extract underscore num, means extract number. Here we need the image underscore file name. So I want the image file name. That's only one argument. Okay, I will read the image. Okay, cv2.imRead. Type the image file name. Image file. Okay. Underscore file. Okay, image file name. So we are reading the image. Next thing what I will do is convert it to gray. I will say here image to gray. Okay, I will say here gray equals to I will say here CVT color. Okay, that comes in CV2. Okay, say here image code. The code will be cv2.color underscore bgr to gray. So now we are also converting the image to gray for processing. Okay, for now I'll just show the image. Show the gray image. Or let's show the default image only. So here result equals image. Okay, so I'm showing the result means the image, and next thing after showing it, I will call the cv2.waitKey as 0 because we are using image. Okay, we are not using video, that's why. If you want to use the video, then set it as 1. Okay, next thing is say here cv2.destroy all windows. Just call it, and there we go. So it will work fine. It will show the image. Okay, oh yeah, it exits because we have not called in it, right? I will call the function, and image file name will be car underscore image dot jpg. And guys, remember one thing, keep the car image in the same folder of the program, and keep the XML file in also the same folder where the image is. Okay, there we go. So guys, it has a very fast performance. Okay, so to exit this, you can just close it, and right over here it will not exit, you will have to terminate it. Okay, so to fix it, what you can do, okay, say here if cv2.waitKey is equals to 113, then what should we do? Means this thing means if we press Q, okay, we will say exit. I will call the exit as it. Just exit will work. Okay, let's see. It will exit the program. Yes, if I press Q, it exits the program. Next thing, it works still exiting and those all stuff. It also shows the result. Let's try seeing the gray image. If you don't know how it looks like, so let me show you how gray image looks like. Okay, so it will be the gray color converted image only. Means if you know the black and white image, it's just like that only. Just press CQ, it will be inside. Now what we have to do is process the image also. So let's start the main coding part. Okay, next thing I will say here endplate equals to. Okay, so before creating the endplate, what I will just do is I have some codes right over here, guys. Okay, so these are the codes. Okay, it's very long. So what's going on here is, if you don't know, I am creating an Cascade using this file. Okay, and then I have an states over here, all the states that which we have. Okay, just align it properly. So let me just do it completely. Wait. So I will just keep 2 or some more in one. You can keep any in one. Okay. So this is my states list. In that, if I see my car image, there is TN written. So what we will do is specify here TN. So it will search in this dictionary. Is it AN, AP, AR? It will just search for these all letters before the colon. And till it finds one, means TN is right over here. Till it finds it, it will just keep doing it. Okay, till it finds. Okay. I'll just align it. And if the car is from Maharashtra, it will go to image and it will work. So these are codes are of India. Okay. If you are looking for anything else, then you can do. So let's create here end plate that we were doing. End plate equals to cascade dot detect multi scale. Okay, dot detect multi scale and specify here gray and 1.1 and 4. So what we are doing right over here, if you haven't understood yet, so first we are creating an cascade from here, okay, and then we are getting the state code, means like the TN for Tamil Nadu, image for Maharashtra. Then we are creating a function image and we are converting a gray image of the main image that we have. And then we are detecting the multi-scale with the gray image. Okay, from this cascade we are detecting. Okay, after getting the end plate, what I want to do is crop the portion, hashtag crop portion. Okay, I want to crop the portion. So to do that, I will say x, y, width, height. Okay, means indirectly what we will do is get the bounding boxes only, and we will just split them in these variables. So from where we will get the bounding boxes, right? That's the question. So we will get it from the end plate. Right over here, what I will do is creating a variable called a and b equals to, okay, it's very simple. I will pass an tuple, means for a and b for both. What means if I say 1 and 1 in this tuple, right over here a will be 1 and b will be 1. So like that only I have to specify the values. First I will convert the value to an integer, okay, and what there will be in that integer will be an float value, which is 0.02 multiplied by image, means y. Okay, indirectly the image that we are getting, the shape of it, and I will get the y. Means if you don't know what's the image shape, okay, for some clear understanding, what I will just do is come in this for loop. Okay, I will say here YT, HT and CT. So here will be yes, WT, HT, CT means width, height and then the channel. So what's the channel? It's of the image shape. Okay, image dot shape. There we go. Right over here I will say multiplied by the width, okay, the width, and what I want to do is next thing also I will I will also do the same thing also for the second. Right over here HT will come. Okay, so it's too simple. So what we are just doing is getting an float value and we are converting it to an integer. So we are multiplying it by 0.02. Okay, 0, and we are multiplying the shape of the images. If you ask, we can also specify directly, but we want to multiply it by 0.2. Okay, right over here I will crop the plate. Okay, means the number plate which we want to do, and right over here for cropping it I will access the image. Okay, now this will be a bit complicated, so I will not explain you in deeps. Okay, you will get more confused if I explain it to you. Right over here y plus a, and from that we want to access y plus height and I will say minus a. Okay, so it's simple as that. Means we are slicing the list, first y plus a, y plus height and minus a. I will not go too deep in it because it's, and right over here also I will say here x plus b and x plus width minus b. Okay, similarly we have also done the same thing to the second argument also, and right over here I will say comma and then colon. Okay, so we have cropped the plate. Let's also see the plate. I am show, in that I will say plate, and I will show the plate. So here is, so you can see the cropped plate that we have. As the output, it's also detecting the plate. Okay, right over here what I will do while showing, means when we are showing this, okay, means when we want to show this I will increase the scale of it. Now after that we are also showing it. Right over here what I will do, I will make the image more darker. Okay, so I want to make the image more darker to identify the LPR. Okay, so this is comment. Right over here I will also write the code for it. So to do that we will need an kernel. Here the numpy we will use numpy.tons. So if you don't know what kernel is, right over here it's just an window, guys. Means what an window, like the IM read we are getting, it's just a blank window. It will show black window to us one by one, and here will be np.uInteger8. We have a kernel. The size of the kernel will be 1 by 1. Okay, so that's our kernel size. Then I will say here plate equals to, I will dilate the plate. Dilate means I will apply the dilation, and I will also apply the erosion. Image and the kernel, and then I will say iteration equals to 1. I will just copy this because we want to do the same thing, just here will come erode. Okay, and here also will come plate instead of image. We do not want to apply it on the image, we just want to apply it on the plate. Okay, so we have applied dilation and erosion. Next thing that we need is let's convert the image to the gray. here we need the plate, and then I will say the code is to color underscore BGR to gray. Okay, cv2.color BGR to gray, all in capital casing. Okay, capital case we have to type here. After that, I also like to take the threshold. I want the threshold, and I will get the plate, means I am again replacing the plate, again processing it. So I am just applying processes on it, and it will be also easier to read with the Pytesseract. Okay, let's see. Here we'll say cv2.threshold, and in the threshold the source is plate, and the threshold, let's keep it as let's keep it as 127. And one more thing, for threshold we will need a gray plate, means the plate gray. I'll just call it plate gray. So the threshold will be 127, and then the max value will be 255, and then the type, let's keep it as cv2.thresh binary. We will not use the INV one. Okay, so we have our plate also. Next thing, right over here, what I will do is I will read the text on the plate. Okay, so to read the text on the plate is very simple. We will use the Pytesseract dot image to string. Okay, image to string. In that, I will pass my image. Oh, no. I will pass my plate, and I will just make it an read variable. I will capture it, and I will say print read. And let's also show the reader, the plate also. Okay, we are showing it. Let's try running it. Okay, it shows the plate as TN87. Okay, TN87 TC195. Okay, so this is the threshold erosion plate that will also give us accuracy. So this is our number plate. So this is the number we want, is that right? That's the number that we want. Right over here, what I will do, I will just take this number only. So how to do that? It's very simple. To do that, okay, let's try this way, because I like doing this type. I like using this type of way. Join. Let's try join only. Okay, so we are using here join, and in that I will say E. So E will be an element in the for loop in, so inside the read. I will say here if, means I am applying an if condition in lists also. I say E dot is a num, isl num. Okay, if it's true, then do that. And let's also get the state as the read. Let's slice the list. Let's also print the status. Let's try it out now. Okay, so we have our number plate as this, So the problem is coming that here the dB is coming extra because okay, it scans from somewhere, it's seeing the dBA. So guys, as you know, sometimes it also has some non-accuracy. Okay, so now I knew it's because of the because the number plate is not accurate, because the image is blur also. Okay, so now we are getting the state as TN. Okay, I'm trying to terminate the program again and again. Okay, I have not practiced pressing Q. Next thing, what I have to do is have the state and the number plate text also. How about drawing it? So we will draw it. But before drawing, as I told you, I will increase the scale of the plate. I'll say plate dot. Okay, let's keep it as default only because it looks good still. Let's draw the rectangle where we'll draw where the number plate is. Okay, we'll draw where the number plate is, image, and then x and y, and then means here we want to specify the x and y, and then width and height. We say x plus width, y plus height. Okay, this is also too simple. This is a regular rectangle drawing code only. Then the color, let's keep it as something bright red type of color. I think this will be bright, and let's keep the thickness as 2. And what I am planning to do, if I just show you, okay, it will draw a rectangle. Yes, you can see that it draws a rectangle over here. So what I am planning to do is create here one more rectangle and type and white text on it. So it will also look good. I am terminating it. Okay, let's go right over here, cv2 dot rectangle, and I'll just copy this, paste it, add image, xy, width, and I am not wanting to the x be the perfect, means the x will be like the rectangle, you can see that will be large, so I will do y minus 40. Actually, we should subtract over here. Yeah, we should subtract over here because we want it up of the rectangle. Okay, if I didn't do plus minus 40, what will happen that the rectangle will be in between of it. That will be an huge problem, so that's why we are using the minus 40. And right over here, what I will do is make it minus 1, means it's just like an shortcut method for filling. Usually what we do is cv2.filled. Okay, usually we use cv2.filled, but this time we type minus 1 filled. And then the next thing, we need to put one white color text, as I told you. Okay, put text. Here I will put it on the image, and the text will be read. Okay, in the text we have read it, and then the xy will be xy, and let's subtract 10 from the y, and then the font face, let's keep it as Hershey or simple X. We will not use the plain because it looks bad. Font scale 0.9. okay, and then the color, as I told you, white. This is the color code for white. Okay, and then the thickness, let's keep that how about 2 will be the same thickness as the rectangle. Okay guys, let's try it out. Okay, so it shows the license plate properly. What I'll just do is just make this rectangle a bit larger. Okay, I will make it a bit large. Let's say +1, a bit only, guys. Yes, from there it's perfect. And from here also we see +1. Okay guys, so the corners we are getting, that will be removed. Wait just a sec. Okay. Let me take it +2 and plus. Yes, now it should work. Okay, so right over +1 is perfect value. Oh shit. Yes. So right over here the +1 is perfect value, but the problem here is that let's try doing. We also want to do from there also. So what the problem that I was talking about is here you can see a bit corner thing. So we are just doing this to remove them, okay? -1. And there we go guys. So you can see now the corners are removed, and right over here you can just ignore the DB8 for now because this thing is blurred. And if you don't know from where I got the car image, you can search here for car number plate image. Okay, then just go to the images and right away you can so the type here IND if you want from India, okay, and just go over here, choose an image whichever you like, save it, okay, and paste it over here and copy it and type the file name of the file over here, okay. So right over here the image is very huge, but it detects it properly. Okay, so if you are also facing the problem that the image is too huge, I have the solution for it. Just say here cv2.resize. We will also see the fixes also with fixes, and resize as none, and then type here fx equals to 0.5 and fy at you can just do -1 from these values till you get the perfect value guys. So now you can see this image is small as we wanted because the scale was also 4K. You can see the plate is also better and the text is also coming perfect. Okay, so the problem with my image was that was a blur. So this works fine. Okay guys, so you have seen that it also works fine, but what if you want to use a video? Then what you can just do is go over here, okay, where you are reading the image, and you can just say here cv2.video capture and write here image file name, okay, and that will work, and specify here the video file name, okay. I will just undo that changes that I made. So that will work for the video. So thanks for watching. That's all for today's tutorial guys.